Okay. Okay. So 0 people watching, so. Find out what things Annie's reading on the internet. Hey, so okay, cool. So I see you're here, and this is my version, which is shorter, and what I did, this line might not be needed, but like for sanity, probably is a good idea. You know, it's not entirely clear what this is. If permute is unbound, or not a list, and then length implies that the first argument must be a list. So I don't actually have to test separately. So I guess actually, you know. The problem is that I really need to have it at least partially bound, so I need to have it. Yeah, my version's a lot shorter. That's why I just went ahead and did it. It's like I wanted to demonstrate that like there's a you know, if you kind of get down to the elegant core, you get things get a lot shorter. So here, here I've got. I want to make certain that it permutes at least a list. I'm not going to figure out what to do if permute's completely unbound. And then, but this thing is the permuted version of this thing with this permute, right? So okay, let's make certain it's a list. And then we'll find out what its length is, because length is going to get bound by that, because since it was a list, it must have some definite length. And then straight must be a list of the same length, and permuted must be a list of the same length. Yes, this version will fail in plus minus plus. That's what I'm saying. And yeah, that's called steadfast. And it probably is not steadfast in plus minus plus. I'm not even certain it'll work in plus minus plus. It might just totally crash. Usually, This is pretty common in Prolog programming, frankly. I know this sounds really weird coming from anywhere else, but yeah, it's not that unusual to have things that just kind of go crazy if you run them in a mode they're not expecting. And yeah, I'm assuming that these are kind of going to be partially bound or unbound, the first and third arguments, and that the middle one is at least bound to a list. So even if it's a partially instantiated list. Suck is a really handy little thing. It's a really old Prolog thing. All it does is succeed. Yeah, it's steadfastness. That's somewhere in the like stuff, but there are a few things I realize I covered a little fast. Modality and then steadfastness. But yeah, steadfast predicates behave reasonably if you backtrack into them. That's what steadfast means. And that's what you described, right? It'll give you one reasonable result, and then when you backtrack into it, it dies. So so this is so yeah, I make a I find out what the max index is one less than the length, and because I'm in a zero-based world here, and then I get a set of unpermuted things, which is just going to be a list of 0, 1, 2. For the example, for the example, it'll be 0, 1, 2. It's just a counting list. And then permutation is built-in because you do this kind of thing so often. And permutation succeeds when its arguments are pure permutations of each other. And in this case, I have unpermute, and then and by the way, permutation is smart. It does something efficient. It doesn't just attempt to count through all permutations. If you pass it something bound in the second argument, it's smarter than that. And then this is something we're going to cover that we haven't covered yet. Doing functional style programming in Prolog. There is a map list operator, and you pass it a goal and a series of lists. It takes that goal and adds that many arguments, right? In one of this week's exercises, you make filter. This is map list, and it's part of it. And then here, I could have used the YAL library to rearrange the arguments, but I felt like I should write pretty, bland Prolog, so I wrote instead a helper predicate, my-nth 0, that just takes its arguments in different order so that I can do the mapping. That's what I built. You want to see me step through it in the debugger? If not, I'll paste it into the Slack and then close out the channel, the broadcast. That'd be great. That I steps through in the debugger. Okay, let me do that. Boom. Okay, so we step in. I'm just using the example. Okay. I'm going to check and make certain that permute is a list, and in this case, I've got everything ground. And then find out its length. I bind length, len, to the length of that. Now, I make certain that straight is a list of the same length. If straight had not been bound, it would give me a list of that many unbound variables. Yeah, there's a huge delay on the chat. Like 30 seconds. And the options are poor video quality or lots of latency. And I chose lots of latency. Okay, and then I do the same thing to permuted. I make certain it's a list of that same length. You know, all I'm doing is I'm cutting off like possibilities, right? So if I had not ground everything, then I tell you what, I'm gonna go back. I'm gonna board out of this, and I'm gonna go back and do that with permuted unbound. Okay. Yep, that's a list. It's of length 3. Okay, and then it gives me permuted. So it's going to give me 3 unbound variables. And then it's going to figure out that 2 is 1 less than 3. One cool thing about suck is that it doesn't go below 0. So if you're doing it for this kind of like incrementing, it'll bounce at 0. It'll fail if max index had become -1, and so you get a free test. Okay, and now this bit of code just calls between and gets a set of the answers, which is just going to be a list of the indices, right? So that's the unpermuted version. And there it is. And then the next thing that happens is I'm going to test, because they're both bound, I am going to test that one is the unpermute and permute are permutations of each other, which is my way of testing that it's indeed a permutation, right? If it's a permutation of the straight version, it's a permutation. It's a permutation by their rules. Okay, now I can perform a map into permuted, and then it will unify with this partially bound permuted. So when I do that, it's going to bind them all. If I okay, you know, it'll drop in, and it's going to give me element 2 of list, so it's going to set val to C, right? And then it'll set val to B, and then set val to A. And hey, I'm done. Yeah. Yeah, knowing the libraries and being able to like use them for, um, rather than you can often use a lot more imagination when applying libraries in Prolog than you can with Java. So, yeah, if you, what's the runtime complexity of that? It's order n unless my nth. Well, nth zero is nth zero is also order n, so it's going to be order n squared. Which is probably almost inevitable as long as your language only has single-ended access and you have and you're performing a permutation. Yeah, it's order n squared in the map list. Yep. Okay, I think at this point I'm going to log off then. But woohoo, that was fun. And of course, by the way, this is because it's not smart enough to realize that it's never going to get another working permutation. Blue choice point. And I'll paste this into the black. You too. See ya.